So this is notes 9, the end of page 2 plus the start of page 3. So we're still simplifying radical expressions. And this problem here is really, can you follow order of operations and work with radicals at the same time? So we'll get the big picture first. There are two terms. And just kind of read this, all right? I have to get whatever this answer is minus whatever that answer is. That's what observing the two terms tells you. It's whatever this answer is minus that entire answer. So you simplify within each term first. So I need to get this answer. That's a FOIL problem. Binomial times a binomial. But wait, it's even easier than FOIL. That's a pattern. Because it's root 3 plus 7 times root 3 minus 7. First and first are the same. Last and last are the same. 1 plus 1 minus. So all I have to do is square the root 3. And if you could do that in your head, great. Minus square the root 7. And that's how that's going to turn out. And so this turns out to be 3 minus 4. And in the next step, I'll call that negative 1. Why did I say 4? It's because I did the subtraction in my head. It's 3 minus 7, which will be negative 4. See how my hand got ahead of myself. If you FOIL it, you will get the same thing. Now, set yourself up for success here. Don't let yourself make careless mistakes. It's minus the entire answer. So to make sure you subtract every term of your answer, go ahead and lay out your parentheses. Now that's the square of a binomial. Use your language. Identify what you're looking at in words. Square of a binomial? Oh, I know how to do that. I'm going to use a FOIL or pattern. Now I'm going to try the pattern. I think I'll have some room to FOIL it for you. But I want to first do the pattern. So to square a binomial, you square the first term. Be careful. If you do this in your head, you're squaring 2 times root 3. That's a product. You square the 2, you square the root 3. Be careful. Some people forget to square the 2. So the middle term will be minus because that's minus. Scoop these together. That's 10 root 3. I don't have much space. Double it. That would be 20 root 3 plus square the second term, which is 525. So I do have to do a little bit more work here. 2 squared is 4. This is 4 times 3 because the square root of 3 is 3. Minus 20 root 3 plus 25. Now, you have some options here. You can go ahead and distribute the negative at this point. That'll be fine. Or you can add inside the parentheses. Doesn't matter. This time, I'm going to distribute the negative first. Usually, I add inside the parentheses first. It doesn't matter. I'm ready to go ahead and say 3 minus 7 is negative 4. Minus 12 plus 20 root 3 minus 25. And now I do have some like terms. What we have is minus 25 minus 12 is minus 37 minus another 4. That's negative 41 plus 20 root 3. And do not even try to combine those. Those are unlike terms. Now, just for the people that don't feel comfortable with the pattern yet, you can always FOIL it. I advise, if the FOIL is in the middle of a big fat problem, to FOIL off to the side. And a common mistake is people want to change the signs for the second factor. No, to square something is this times itself. Okay, first times the first is 2 root 3 times 2 root 3. Outer is minus 10 root 3. inner is another 10 root 3. Oh, that's why we doubled it. Negative times a negative, that's positive. That's why that last term is positive. And then here, I have 2 times 2, which is 4. Then root 3 times itself is 3, so that's 4 times 3. Minus 20 root 3 plus 25. 4 times 3 is 12, so this is 37 minus 20 root 3. And that's what I would have had inside here if I had gone ahead and added first. So what I would do if I was doing this off to the side, I'd have my blank parentheses open and I would write the 37 minus 20 root 3 inside those blank parentheses. Then distribute the negative. All right, so let's go on to page 3, the first part of it. One comment here. We're moving as fast as we can, but I can't see any way of getting in rationalizing the denominator. We're supposed to cover this, but I'm skipping it. If you get a good handle on radicals and you need to rationalize the denominator sometime in calculus, you'll be okay. You'll see it done and go, oh, I got this. So we aren't going to be doing that. We are going to be doing this type of problem, which is hugely important. So this one, very important. Okay, simplify. Notice, big picture, it's all one term because the fraction bar acts like parentheses, so it's basically this divided by that. But there are 2 terms in the numerator. Do not even think about canceling terms in the numerator when you're dividing. It doesn't work. We've discussed that. So, when you see a problem like this, there's basically 2 steps. The best thing to do first is simplify the radical if you can. All right, root 24. 24 is not a perfect square, but 4 divides into it. So that's negative 6 plus 4 times 6 over 2. So that's negative 6 plus 2 root 6 over 2. Now, the second thing you do is see if you can reduce. And there'll be 2 ways to reduce this. I'll show you both ways and use whichever you like the best. One thing that's good to be able to do is look at that and say, oh, can I reduce this? Well, you're going to be able to reduce this if you look at each term. There's 2 terms in the numerator, 1 term in the denominator. Is there a number that divides evenly into all of these 3 terms? If the answer is yes, then you can reduce this. If the answer is no, you can't reduce it. So this one's a yes. 2 divides into all these terms. So I can reduce this. Way 1. Remember, if you add fractions, 1/7 plus 3/7, as long as you have a common denominator, you just add the numerators as 1 plus 3 over 7, right? So we can always go backwards. If you have 2 terms in your numerator, you could split that into 2 separate fractions. So that's one way. I can take the negative 6 over 2 plus the 2 root 6 over 2. Now, I don't have 2 terms in that numerator. I can go ahead and reduce. This fraction is just negative 3. And here, I don't have 2 terms in this numerator, and I can think of this as 2 times 1. So I have factors. When you're reducing a fraction, you can cancel identical factors, so I can cancel the 2's. So that's just negative 3 plus root 6. So that's way 1. This way works really well when your final answer has no fractions. The second way is almost better when your final answer winds up having fractions, but it really is 6 one way, half a dozen the other. So way 2 is to factor the numerator. Now, We haven't factored with a radical, but the radical is not really changing anything. First step in factoring is a GCF. And for these problems, that's all you'll ever have to factor out of the GCF. GCF is 2. So the numerator would be 2. Open your blank parentheses. 2 times what gives you -6? That'd be -3. 2 times what gives you 2 root 6? That'd be plus root 6. And this is still over 2, and you can think of that as 2 times 1. So now you have identical factors in your fraction. You can cancel identical factors when dividing, and you're left with -3 plus root 6. Again, it doesn't matter which way you decide to reduce. So at this point, pause the video and try this problem here. Okay, I'm going to go ahead and go over it. So it's basically 2 steps. Simplify the radical first. All right, looks like a big number, but hopefully you realize 100 goes into 300. So yes, I can simplify the radical. I'm going to write that as 3 times 100 all over 10. And then the square root of 100 is 10, so that's 15 minus 10 root 3 all over 10. Now, can you reduce this? You should always check. We'll look at your 3 terms, the 2 in the numerator, the 1 in the denominator. Is there a number that divides into all 3 of these? Yeah, 5. That means you can reduce this. So I'll first start by factoring it. So factoring just the numerator is that 5 is the GCF. So that leaves you with 3 minus 2 root 3 all over 10. And you can think of that 10 as 10 times 1. And then 5 goes into 5 once, into 10 twice. And so the fraction, the denominator did not clear. So this is 3 minus 2 root 3 remaining in the numerator over 2. And don't even think about trying to cancel this 2 with that 2. You can cancel factors of the entire numerator. You can't cancel factors of part of the term of the numerator. So this is it. Now, the alternate way would be to say, all right, I'm going to divide the 10 into both of these terms. I'm going to separate this into 2 fractions. So that'd be 15 tenths minus 10 root 3 over 10. And then reduce within each fraction. 15 tenths is 3 halves minus. Now here, yes, I can cancel the tens because that is a factor of the entire numerator. Over here, this 2 is not a factor of the entire numerator. I cannot cancel that. So I can cancel the tens, and that just leaves me with root 3. We should do that in black. So either form of the answer is correct. Notice, if I wanted to get a common denominator for these 2 terms, I would multiply this top and bottom by 2 over 2, and I would get exactly this. One last comment before I leave this problem. If you wind up with an expression like this and you cannot simplify the radical, so like you had, I don't know, 6 minus root 11 over 2, if you can't simplify the radical, you can't simplify anything. It's done. That is simplified. So remember the process. See if you can simplify the radical first. If you can't, there's nothing you can do. Once you've simplified the radical, see if the fraction will reduce. And I'm hoping some of you recognize this expression. Have you guys ever heard of the quadratic formula? Yeah? Well, when you use it, you get things like this. So we need to be able to deal with it. So we're going to look at the next part of page 3 on the next video.